Hi Irene, I hope this is recording. I thought it best just to talk you through the Excel sheet because it's gotten pretty messy at the moment. What I did was I took your data from data for log linear and I created a new data set, well a new sheet, because Excel wants all the data in one long column. And so taste, I converted words to numbers for taste, country and shape. And anyway, so I did that. I stuck it into SPSS and I conducted like an overall chi-square. Now, maybe I'll quickly show you the proper way, the way I ended up doing the chi-square, because it looks like SPSS is being a pain. I can do it over here. So what I did was, I'm just going to unsplit my file. And I think we've already got weighting on. Cool. And analyze log linear model selection options, and you want association table, which gives you nice chi-square values to report in your analysis. And we're missing shape, so if I recall, 28 shapes. So 1, 2, 28. I think that's good. We click OK, and over here we have that overall log linear analysis. Let's just shrink this data output screen, and so I most certainly hope that this log linear analysis is identical to the one that we've just run. SPSS is not behaving today. Okay, let's have a quick look. 5149.952, 5149.492. So it looks pretty nice. Well, anyway, the cool thing about partial associations is that it's like an ANOVA table. It gives you it's a fully factorial design, as it were. So it gives you all of the nice interactions between effects. So as you can see, these effects all line up quite nicely. And because our main effect is significant, we had to ignore. Actually, sorry, that's not the main effect. I mean the triple interaction. Triple interaction is this guy, bizarrely. Because that's significant, we then go on and not explore the lower order effects, as one does with ANOVA as well. So what I did was, I gave that as justification to do further log linear tests. And here they are. It's I think I'll make that a bit bigger because it's pretty important. So split by shape, alpha divided by 28 is not correct. Okay, this is my thinking. So we're interested in testing whether or not our different countries respond differently to the different shapes, and assign those shapes as the different flavours or tastes. Now, we're interested to know either whether or not those countries do not differ or whether they do differ. If we apply a Bonferroni correction, a multi-comparison correction, then what we're doing is we're biasing our results to fall more under the category these countries do not differ. And in actual fact, we don't want that. We're interested. So because we have like a two-way effect here, we're interested in both directions to which the result lands, whether or not there's no significance, whether or not there's significance. And I actually think the justification for not using a Bonferroni correction for these 28 different separate chi-squares for each of those different shades because of that. Let me know what you think. But it's kind of intuitively, it kind of feels like the right sort of thing. Well, anyway, we can discuss that over email as well. So here are 28 separate log linear tests for each of the chi-squares. Sorry, each of the shapes. And I just cluster them according to output because it just makes eyeballing a lot easier. Now, if you scroll the whole way down to row 588, this is where the more interesting stuff happens. So here we have shape 1, and we can see that the end model used is country and shape. So we need to do separate. Essentially, this is the end of the analysis for this one particular shape. I think it's black, and appropriately we see that bitter is more so assigned to black than the other conditions. And if you notice, we had two main effects. Were country and taste. Now, country, in actual fact, is not interesting at all because it's identical for over all. There have been an identical number of participants over all the categories. So this effect is absolutely not interested. Note the small Malaysia N. I'm a bit worried about that, but I think we're okay with log linear. I don't think it's biases of effects according to sample size for one given group. Anyway, we can discuss that later on anyway. What the most interesting thing are these different values here. But how on earth do we do postdoc tests for this? And that's really, really tricky. I don't think we can actually do a traditional test, although I think we can do some simulations. Because if you think of it, these are totally not independent of each other. High value here means small values elsewhere, just by the very nature of how the data is collected. So I think we could just I could do a simulation at some point to see the probability of one or more values actually being higher than this value. In actual fact, I will identify p equals 0.05 and what's the likelihood of there being one or more values over a given value for 0.05, and likewise for 0.01 and 0.001. Anyway, when we get for a given log linear only main effects of country and taste, then in my eyes that demonstrates that there's no difference over the countries for the allocation of this given shape to bitter, salty, sour, sweet, umami. But when the model keeps the interaction between country and shape, then we can argue we have statistical evidence that these countries do differ. Now, I was going to have another table over here on the right hand side, but I thought this would just be too complicated. So what I did was I looked at all of these stimuli, stimuli 1, stimuli 2, stimuli 3, stimuli 4, etc., and looked at all of them that had a significant interaction between country and taste, and I scrolled down and I just conducted bog standard 1 times 5 chi-squares somewhere down here. If the significance value, just ignore that. Anyway, so here are those 1 times 5 chi-square tests, and here we see for shape 2, for country 1, I think that's China, I'm not too sure. We see a main effect for shape 2, but not for country 2 and 3, but also for country 4. Now I think we can actually apply bond for any corrections here, but I still need to think about it anyway. I mean that's how things stand in the analysis at the moment. Unfortunately, the program that I'm using to record this screencast only gives me 10 minutes of recording, and I think I have about 30 seconds left. So do get back to me, and let's all kind of scratch our heads and think about how to proceed from here. Anyway, cheers, bye bye.